Falcon 9 by SpaceX. Falcon 9 is a reusable two-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of people and payloads into Earth orbit and beyond. Falcon 9 is the world's first orbital-class reusable rocket. Reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of space access. Falcon 9 is a partially reusable two-stage-to-orbit medium-lift launch vehicle designed and manufactured by SpaceX in the United States. The latest version of the first stage can return to Earth and be flown again multiple times. Both the first and second stages are powered by SpaceX Merlin engines, using cryogenic liquid oxygen and rocket-grade kerosene, RP-1, as propellants. Its name is derived from the fictional Star Wars spacecraft, the Millennium Falcon, and the 9 Merlin engines of the rocket's first stage. The rocket evolved with versions V1.0, 2010-2013, V1.1, 2013-2016, V1.2 full thrust, 2015 present, including the Block 5 full thrust variant, flying since May 2018. Unlike most rockets in service, which are expendable launch systems, since the introduction of the full thrust version, Falcon 9 is partially reusable, with the first stage capable of re-entering the atmosphere and landing vertically after separating from the second stage. This feat was achieved for the first time on Flight 20 in December 2015. Since then, SpaceX has successfully landed boosters over 100 times, with individual first stages flying as many as 11 times. Falcon 9 can lift payloads of up to 22,800 kilograms, 50,300 lb, to low Earth orbit, LEO, 8,300 kg, 18,300 lb, to geostationary transfer orbit, GTO, when expended, and 5,500 kg, 12,100 lb, to GTO when the first stage is recovered, in a cargo shroud offering 145 cubic meters of volume. The heaviest GTO payloads flown have been Intelsat 35E with 6,761 kg, 14,905 lb. The latter was launched into a lower energy GTO, achieving an apogee well below the geostationary altitude, while the former was launched into an advantageous supersynchronous transfer orbit. In late 2021, a Falcon 9 was used to launch the X probe into equatorial orbit from KSC with a post-launch orbital plane change maneuver. In 2008, SpaceX won a commercial resupply services (CRS) contract in NASA's Commercial Orbital Transportation Services (COTS) program to deliver cargo to the International Space Station (ISS), using the Falcon 9 and Dragon capsule. The first mission under this contract launched on 8 October 2012. Falcon 9 has been human-rated for transporting NASA astronauts to the ISS as part of the NASA Commercial Crew Development Program. Falcon 9 has been certified for the National Security Space Launch Program and NASA Launch Services Program as Category 3, which can launch the most expensive, important, and complex NASA missions. Falcon 9 has been considered the world's most advanced space launch vehicle by various sources. As of January 2021, Falcon 9 has the most launches among all U.S. rockets currently in operation, and is the only U.S. rocket fully certified for transporting humans to the International Space Station, and the only commercial rocket to launch humans to orbit. On 24 January 2021, Falcon 9 set a new record for the most satellites launched by a single rocket, carrying 143 satellites into orbit. 5 rockets of the version 1.0 design were launched from June 2010 to March 2013. Version 1.1 conducted 15 launches from September 2013 to January 2016. The full-thrust version has been in service since December 2015, with several additional upgrades within this version. The latest full-thrust variant, Block 5, was introduced in May 2018. It features increased engine thrust, improved landing legs, and other minor improvements to help recovery and reuse. The Falcon Heavy derivative, first flown in February 2018, consists of a strengthened Falcon 9 first stage as its central core, with 2 additional Falcon 9 first stages attached and used as boosters. SpaceX plans to eventually replace Falcon 9 and Falcon Heavy with the much larger, in-development Starship launch system. Falcon 9 testing begins. On November 12, 2007, SpaceX announced that it had completed Merlin 1C engine development with a 172nd H test at its Texas test facility near McGregor, Texas. The development engine test program included 125 hot fire tests, totaling more than 3,000 seconds duration. This first Merlin 1C could produce 43 tons of thrust at sea level and 49 T in vacuum. SpaceX shipped its first Falcon 9 first stage to McGregor in mid-2007. The stage was erected into the company's masked Big Falcon test stand during August. During November 2007, the first Falcon 9 hot fire test, using only one Merlin 1 engine, was performed. This was followed by a 2-engine test in January 2008 and a 3-engine test in early March. 5-engine testing occurred in late May 2008. The first 9-engine test was performed on June 31, 2008, in a test that produced 385.5 tons of total thrust. 2 more less than full-duration 9-engine tests followed. On November 23, 2008, SpaceX performed the first full-duration 9-engine Falcon 9 test at McGregor, producing 3 tons of total thrust while burning nearly 227 tons of propellant. The burn lasted 178 seconds. 2 of the 9 MER engines shut down as planned after 160 seconds, a sequence that mimicked the planned flight shutdown method. The late evening test startled Central Texas residents more than miles away. Testing at McGregor used a battleship-type run tank. After the full-duration test, SpaceX planned to remove the run tank and send its engines to Cape Canaveral, where the 5 Falcon 9 flight stage was expected to arrive by the end of 2008. That flight stage was expected to be used for facility testing at SLC-40, culminating in a static test firing in early 20. Another flight stage was expected to arrive at McGregor for formal qualification testing. One of these stages would presumably perform the inaugural Falcon 9 launch sometime in 2009. New Falcon details emerge. In April 2008, SpaceX revealed new details for the higher-thrust Merlin 1C that would power both Falcon 1E and a Block 2 version of Falcon 9 that would fly in 2010 or later. T-upgraded Merlin 1C would produce 56.69 tons of sea-level thrust and 63.45 tons of thrust in vacuum, 1.5-1.6 times more than the original Merlin. With more available liftoff thrust, Falcon 1E and Falcon 9, Block 2 both grew substantially heavier and more capable. The Block 2 Falcon 9 would be able to lift nearly 10.5 tons to LEO from Cape Canaveral and 4.54 tons to a 28.5 deg GTO. Stage recovery attempts were planned when light payloads were launched, with unused payload mass apparently assigned to recovery hardware. Block 1 Falcon 9, powered by the initial lower-thrust Merlin 1C engines, would prefer early COTS demonstration flights. Development. SpaceX originally intended to follow its light Falcon 1 launch vehicle with an intermediate-capacity vehicle, the Falcon 5. In 2005, SpaceX announced it was instead proceeding with the development of the Falcon 9, a fully reusable heavy-lift launch vehicle, and had already secured a government customer. The Falcon 9 was described as being capable of launching approximately 9,500 kilograms, 20,900 lb, to low Earth orbit, and was projected to be priced at $27 million per flight with a 3.7 meters, 12 ft, payload fairing and $35 million with a 5.2 meters, 17 ft fairing. SpaceX also announced the development of a heavy version of the Falcon 9 with a payload capacity of approximately 25,000 kilograms, 55,000 lb. The Falcon 9 was intended to enable launches to low Earth orbit, LEO, geosynchronous transfer orbit, GTO, as well as both crew and cargo vehicles to the International Space Station, ISS, testing. The original NASA COTS contract called for the first demonstration flight of Falcon in September 2008 and the completion of all 3 demonstration missions by September 2009. In February 2008, the plan for the first Falcon 9/Dragon COTS demo flight was delayed by 6 months into the first quarter of 2009. According to Elon Musk, the complexity of the development work and the regulatory requirements for launching from Cape Canaveral contributed to the delay. The first multi-engine test, with 2 engines connected to the first stage, firing simultaneously, was completed in January 2008, with successive tests leading to the full Falcon 9 complement of 9 engines, test fired for a full mission length, 178 seconds, of the first stage in November 2008. In October 2009, the first flight-ready first stage had a successful all-engine test fire at the company's test stand in McGregor, Texas. In November 2009, SpaceX conducted the initial second stage test firing lasting 40 seconds. This test succeeded without aborts or recycles. In January 2010, a full duration, 329 seconds, orbit insertion firing of the Falcon 9 second stage was conducted at the McGregor test site. The full stack arrived at the launch site for integration at the beginning of February 2010, and SpaceX initially scheduled a launch date of March 2010. However, they estimated anywhere between 1 and 3 months for integration and testing. In February 2010, SpaceX's first flight stack was set vertical at Space Launch Complex 40, Cape Canaveral, and on 9 March 2010, SpaceX performed a static fire test, where the first stage was to be fired without taking off. The test aborted at T2 seconds due to a failure in the system designed to pump high-pressure helium from the launch pad into the first stage turbopumps, which would get them spinning in preparation for launch. A subsequent review showed that the failure occurred when a valve did not receive a command to open. As the problem was with the pad and not with the rocket itself, it didn't happen at the McGregor test site, which did not have the same valve setup. Some fire and smoke were seen at the base of the rocket, leading to speculation of an engine fire. However, the fire and smoke were the results of normal burnoff from the liquid oxygen and fuel mix present in the system prior to launch, and no damage was sustained by the vehicle or the test pad. All vehicle systems leading up to the abort performed as expected, and no additional issues were noted that needed addressing. A subsequent test on 13 March 2010 was successful in firing the 9 first-stage engines for 3.5 seconds.